listeners, welcome at this episode in the fourth season of Meet the Expert series. In this podcast series, together with well-known experts from around the globe, we'll explore challenges and opportunities in the pig veterinary world. And in this episode, we will spend attention to gut health, and more specifically, we shall look at Lawsonia intracellularis, causative agent of porcine proliferative enteropathy, commonly known as ileitis, and how the bug interacts with the microbiome. With us today is Professor Christian Fischer, attached to the University of Veterinary Medicine in Hanover, Germany. Welcome, Professor Fischer.
Hello.
The Meet the Expert podcast series is a co-production of Boehringer Ingelheim Animal Health and Pig Progress. My name is Vincent de Beek. I'm editor of Pig Progress and I'm the host of today's episode. And present at this podcast is also audio-visual editor Iris Hofman, without whom this podcast wouldn't be possible. Our guest today, Professor Fischer, is attached to the University of Veterinary Medicine in Hanover, Germany. At the moment, he's 44 years old and he did a postdoc at the university until 2007. He worked for several years in a veterinary clinic and also worked for Boehringer Ingelheim for various years, before returning to the world of academia. He's been with the university since 2014. Now, welcome once more, and we're pleased and honored to have you in our podcast. And your expertise is a very interesting one. It is roughly at the crossroads of animal nutrition and animal health, I would say. What makes that place so interesting for you? Could you explain a little bit about that?
Yes, I think it's a topic itself because it's, as a whole, very interesting for me. It also concerns us as humans, and good healthy food keeps you fit. It's the same with animals, I think. We often talk about dietetics in my profession, and dietetics is something for veterinarians who are also interested in nutrition. They have to know about the pathogen and understand a little bit about nutrition in order to develop recipes from it. And that's what's our daily work, and we do this, and that's the kind of beauty in this job, I think. This would be the main topic.
I see. Is there a special name for it where nutrition meets health, so to say?
So the special name is dietetics itself.
Dietetics.
So it means dietetics, yes.
Excellent. Well, I think it's good to start this podcast taking a quick lecture on the backgrounds of ileitis again, for all those listeners who don't have the exact details right at hand. Could you briefly introduce ileitis again? Things like the causative agent, how does it transmit, clinical signs and treatments, perhaps?
Yes, of course. If you talk about Lawsonia intracellularis, it's the most economically important bacterium and of major concern to the pig industry worldwide, I think. And also in European countries, it's quite far widespread, and I think about in 90% of the fecal samples you will find Lawsonia intracellularis, and therefore it's quite important to deal with this bacteria. And if you talk about the clinics, the clinical presentation can be acute, can be chronic, or can be subclinical, and the clinical signs itself whether depend on the form of the disease, which could range from mild to severe diarrhea, decreased feed consumption, and poor growth, for example. And if you have to deal with a chronic form, the called porcine intestinal adenomatosis, you will see this far often, and there's another form with sudden death in case of the acute form. It's called the proliferative hemorrhagic enteropathy, and these are the most two forms which you can see clinically and distinct from each other. But with the age, it's mostly between 6 and 20 weeks, and most of the farmers and veterinarians will talk about PR. And you will see often subclinical forms, which you might be remember only in the performance goals, which are not met, and therefore it's a quite very hard topic for a farmer, could be.
I see. And what kind of treatments are currently available?
Currently available are a lot of treatments. The old ones deal with antibiotics, and the newer ones, what does mean newer ones? Since years you can use vaccines to deal with pathogens, and therefore on the market there are more than one vaccine, and therefore it's very helpful to counteract the disease. But it does not prevent infection itself, but the transmission will be a little bit slower and the gut load will be lower, and therefore you always deal with the clinical signs of disease.
I see. And I think one of in the slides that you said that it is prevalent about in 90% of the farms. Did I get that well? So
yes.
With some pathogens, you could say, okay, this farm is free of that, but in this case, it's just all over the place, basically.
No, I don't think that you will find a farm which is free of Lawsonia. Even if you talk about, for example, SPF mini pigs, you can find serological answers. We did it on ourselves in our facilities, and I think it's nearly impossible to find for a longer time farms which are free of.
I see. Well, it is good to keep that in mind, that it is that persistent everywhere. The other part of this podcast is related to the microbiome. Let's also zoom into that a little bit deeper. What again is the microbiome, and why is it so important to know about it?
Yes, this is a wide topic from the last 10 or 20 years. The term microbiome refers to the totality of all microorganisms you can find in the gut. The accumulation of these microorganisms in a defined environment is called the microbiota, and the composition of the microbiota varies from animal to animal. Mostly these consists of bacteria. These make the majority of the microbiome. And if you think about the intestine, the number of the bacteria living on and in the body is higher than the number of cells in the body. And most of these bacteria colonize the gastrointestinal tract. And in many cases, these bacteria fulfill important tasks, for example, in the production of vitamins and the displacement of pathogens. And also there could be an influence on the immune system.
I see. And correct me if I'm wrong, but I have the impression that the word microbiome is a bit of a buzzword lately. I have the impression that with the increased technology, it is possible to start knowing a lot more about what's going on inside the gut of pigs. So that also the microbiome becomes more important, because all of a sudden technology allows us to know more and more and more about what's going on in there. Am I right in that? Thinking that?
Yes, you are right. There's a huge possibility to deal with this topic because the techniques are there. You have newer sequencing technologies, and you can reveal the diversity of this community, and it improves the possibilities to determine its taxonomic composition. And these studies of the microbiota are carried out using these molecular methods. They rely on specific marker genes, and from this point and with the data from specific banks, you can say what you will find within a pig. But the most big problem is that you need two persons. You need a bioinformatician to deal with the data, and you also need the veterinarian or the farmer who knows about the clinical signs you see, or you can annotate to the samples. Therefore, you must know what you see, and you must you must deal with these data to have a conclusion about the clinical signs in your farm. And this is the problem or the big topic you have to deal with.
Yeah, it makes perfect sense. One cannot do without the other.
Yes, you're right.
I see. And I understand that the microbiome is dependent on a lot of different things. I think it can change depending on the age of the animal, depending on the breed, gender, diet, health. I think there's so many things that influence that microbiome. It's never constant, is it?
Yes, you are right. So these different bacteria in the gut are in balance normally and regulate each other, but this balance can protect against colonization by pathogens or a proliferation of these within the microbiota. And therefore, accordingly, a healthy microbiota could be understood as a microbiota of a healthy host that has the ability to quickly and completely return to the baseline after a disruption, and therefore prevent the slide towards dysbiosis. And so it contributes a little bit to the resilience of its host.
Mm-hmm.
And diet can be, in this potential topic, a very potent means of altering also the microbiota and the metabolites of the diet, and the microbiota can promote resistance to pathogens and so on. So dietary interventions are possible means of interventions.
Mm-hmm.
And there are a lot of, you said it already, there are a lot of factors who can deal with the microbiota: animal, breed, gender, and the health itself. And in the absence of disturbance, the microbial community oscillates around the stable state and exhibits dynamic equilibrium. And therefore, you must be aware that these topics, for example, a very huge amount of feed can disturb this microbiota. And if the animal, for example, eats a little bit less of a diet, then the microbiota also returns back to its original and therefore reaches this equilibrium. And the new state can be eubiotic if you have a quite big factor, but dysbiotic phases also possible, and therefore it's the most important thing would be to reach a resilience of a eubiotic microbiota which protects against disease, and while a resilient dysbiotic microbiota, for example, can cause also disease. These are the main aims on dealing with diet and microbiota.
I see. And just what you said about a healthy microbiome is basically, if there is a disruption, a microbiome will be able to kind of go back to what it was before without too much trouble.
Yes. So this would be the most beautiful thing, and this is also possible for a healthy microbiota.
Okie dokie. Now, this podcast is all about Lawsonia. So I would like you to take us a little bit at the microbiological level. What is happening when Lawsonia, what kind of influence does Lawsonia have on a microbiological level on the microbiome?
There are different things what can happen if you have a problem with Lawsonia. These could be direct effects on the animal itself. This means the animal feels a little bit of sickness, therefore the feed intake will be lower, and therefore you have a different kind of fuel for the microbiota in the gut. And therefore this is a direct effect of sickness on the microbiota depending on the nutrients coming into the pig, for example. Mm-hmm. And also there are effects of the pathogen itself on the microbiota, because if you have problems with epithelium cells and higher turnover of these cells, you will have a different fuel for the microbiota in the intestine itself, because for example, we did not talk about botane, for example, but if you have a high load of Lawsonia, it could be that you have a higher epithelium turnover, and therefore you have more amino acids of specific kind. For example, tryptophan you will find in higher amounts in the gut, and tryptophan itself, for example, is a fuel for building scatole, and therefore you can even have a different smell if you have, for example, a very, very high load, for example, of Lawsonia. And therefore, it's a very complex system, and there are direct effects and there are indirect effects, and you have to think always between pathogen, animal, reaction of the animal, and the specific effects of a diet, for example.
I see. So the effects can range from an animal having less feed intake to, well, flat out disease, so to say.
Yes.
Yeah. I see.
This
Diarrhea.
would be the whole range. Yes.
Yeah. I see. And no, it's clear producers will notice that because, well, you've got animals that don't do well, or perhaps in the end, when the animals are brought to slaughter, that they've been slow growers. What could a producer or a veterinarian do when they observe a problem related to ileitis? Microbiome is wrong, so to say.
I think an expert like a farmer or a veterinarian can already see this problem, because you may not be able to see it directly on the dropping if it's Lawsonia or maybe a specific kind of Brachyspira. There's no red warning light, but usually it starts probably earlier. There are many factors that affect the stability and the expression of the microbiota. And therefore, you might have an idea of your microbiota in your farm is resilient and is a little bit more affectable for diseases. And a healthy diet, therefore, is undoubtedly a major contributor for promoting this good microbial community that turns out also to be crucial for fine-tuned symbiotic relationship with the host.
Mm-hmm.
And I think you can see it on the pig, because the feces will have a different quality. And if there are sometimes days where you have trouble with feed technology and therefore feed intake might decrease for a few hours, for example, they will be more resilient if you have a healthy microbiota. And otherwise, if there's a problem in general in the herd, maybe it's a little bit more trouble will come earlier. And therefore, a balance between host and gut microbiota is crucial to keep a healthy intestinal barrier and an optimal immune homeostasis, and therefore does contribute to prevent disease occurrence, I think. And therefore, you must think about different measures. It could be an vaccination against Lawsonia and all the other things to reduce the spread of the pathogens between different stages of production also.
Yeah, so in that case, you would prevent it from, well, causing problems elsewhere in the pig house.
Yeah.
Yeah. I see. Well, you've been doing some really interesting research to Lawsonia and the microbiome. And to go deeper into that research that was published in October last year, I would like to invite my colleague Iris. She has some questions about that in specific.
Yes, hello, Dr. Fischer. I'm excited to ask you a couple of more questions about the recent study that was carried out by your team, which was published in October 2022. So basically, your team compared microbiota of pigs that got orally vaccinated against Lawsonia and pigs that didn't get vaccinated against Lawsonia. What was the goal of that study?
Yes, the goal of the study, or the aim of the study, was to compare the fecal microbiota of these vaccinated piglets, of non-vaccinated piglets. And concerning the non-vaccinated piglets, we differentiated between those without clinical symptoms and those with moderate clinical symptoms, to address mainly two questions. First, whether vaccination alters the intestinal microbiota under natural occurring infection. And second, whether the microbiota differs between the non-vaccinated animals with and without clinical symptoms. And for that, the results from this evaluation could maybe help to better understand the potential interactions of these host microbiota and Lawsonia intracellularis. And therefore, it could be possible to identify bacteria that are potentially related to the protection against or a clinical onset of the disease. This was the aim when we started the studies.
Yeah. And could you briefly explain the setup of this study?
Yeah, I can do this. The investigations took place in 3 independent repetitions. We had in total only 27 piglets, but the piglets were the main topic. It was a huge work to get these piglets. The piglets were obtained from a farm with about 400 sows, and we had to find a farm with a clinical disease in the early phase of piglet rearing, and this was quite not that easy as we mentioned it would be.
Yeah, it was hard to find.
It was a little bit hard to find these farms.
Why then?
Because when we started the study, the infections took mainly place in the fattening phase, in the middle of the fattening phase, and we would like to make also digestibility trials, and therefore we tried to get piglets as early as possible, and therefore we needed a farm which had a very early infections those days, and this was quite a hard job.
Yeah.
But we found a good farm, and therefore we found from these 27 animals, 25 were naturally infected, and therefore it was quite good. And from this farm, we brought roughly 3 groups. One group got vaccinated at 21st day of life. The other pigs went their normal way in the farm, and at the day of, or in the week when we normally had the infection with Lawsonia intracellularis, we made the clinical examination of about 450 to 500 piglets to see which of the animals are quite good concerning clinical signs, to put them in these different groups. Therefore, we had this vaccinated animals, we had animals with Lawsonia intracellularis pathogen in their gut without clinical signs, and we had also one with moderate diarrhea and with a detection of Lawsonia intracellularis. And these animals, we put them into a transporter, and then we started the trials at the university here at our facilities to have this microbiota from the farm directly transferred into the facilities here at the university. And then we started with, for example, digestibility trials, and we also took the samples to deal with the microbiota analysis.
Yeah, and I'm curious, what kind of differences did you find?
We found a lot of differences in the 3 groups. The vaccinated animals had the far highest body weight growth, and the animals with the moderate clinical signs grew a little bit slower, but in general the performance was quite good. But the digestibility, for example, of the protein was decreased if we had this clinical signs of disease. And if we go further down to the microbiota analysis, we tried to compare the different groups, and we could find some of the bacteria or from the families were only in different groups and could be related a little bit to the clinical findings in the animals. And therefore, it's quite a good first step to think about specific families which might be related also to the pathogen Lawsonia intracellularis.
Yeah, exactly. And there were also certain pigs who developed diarrhea. Can you explain why that happened to some and not to others?
This is a very difficult question. In my opinion, it depends on the situation in which the pig is currently and in which it was born. Basically, we had these pigs from one farm, but we monitored the pigs weeks per weeks, and you can. It's hardly not to see which animals will get this moderate diarrhea weeks before, because this could be also smaller ones, but also bigger ones. So you have to have you must have a good clinical eye to look at the clinical manifestations very early, and you can see it on the feces. It's clear. Farmers do know this. Vets also. So what we could see and what's known from literature, the more Lawsonia you have in the feces, the more pronounced is also the diarrhea. And why is an animal more susceptible to infection for this? On the one hand, it needs a certain amount of pathogen, I think, with which it comes into contact. This is somewhat related also to a chance to get this contact. Then it needs a certain immunity situation. This varies depending on the animal. If you think about 20 piglets born from a sow, there are huge ones, there are smaller ones, and therefore this also refers to the immunity situation. And then there's also whether the animal may also be struggling with other pathogens, for example. And so these are all additive, many different factors you have to mention. And in our study, we had really to examine a large number of animals to have these specific animals, to have these fine groups with a natural infection, because we didn't push every animal with an experimental dose of Lawsonia intracellularis. We need this natural infection on one point, and this is quite not so easy. So I think it's hard to predict what's going to hit these individual animals. Basically, what we see or what we saw in other studies, that if you have a subclinical infection with Lawsonia and you, for example, transport these animals to another facility, or in our case to the university, you make a regrouping, then you can optimally trigger the problem when there's a latent presence of the pathogen. This works, I think, very good. For example, we did this twice with boars. We did this also in a trial where we dealt with a feed additive, for example. And therefore, it's quite possible to have also natural infections under controlled conditions.
Exactly. So a lot of factors that could be a thing. Okay. So what could that mean? Could this all mean for producers?
For producers, I think Lawsonia is a little bit different from other pathogens, but most of the procedures you can do on your own farm correlate to the other procedures you have to have a good management or good cleaning and so on. You simply cannot do enough yet, because then there's no freedom. There's no specific pathogen-free farm concerning Lawsonia. Therefore, you have to deal with the pathogen, and therefore I think you have to deal with vaccines, because this in the past we only talked about antibiotics, and nowadays we are only talking about vaccine. And I think this will be as a way where we have to go in future. Therefore, I think this is a lot of things you can do: vaccine, cleaning, animal management between different parts of the farm, and so on.
Yeah.
The holistic approach again, huh?
Yes.
Exactly.
Totally holistic.
And overall, are you happy with the results of the study?
Yes. We we are always happy. No, I think we know before about the effects of Lawsonia intracellularis infection under experimental infection, and therefore there were also results from the microbiota analysis, and these were in parts identical to our results, and therefore I think it was a good good model to try to see the effects also under natural infection conditions under a control way of procedure.
Exactly. Well, thank you very much. Those were my questions for now.
Thank you, Iris. So if I gather this well, listening to this all, the outcome of the study hasn't been surprising you that much.
No, we expected that the digestibility, for example, would change, and we also saw this change. We expected the microbiome to change, and we also saw this change, and we also saw specific things like more Prevotella in different groups, and this was in line with the results from experimental studies from other research groups. So our results were similar to these ones, and therefore we were quite happy that we are in line with other studies.
I can understand that. Now, we've heard a lot about Lawsonia vaccination, but if you would do a similar trial to, for instance, Salmonella vaccination, would you find also outcomes like this, that the microbiome also, you can find adjustments in there?
I think in general, if you have a vaccine which deals also with the local immunity, this could have an effect also on the microbiome as well. But I think you have to think about the pathogen itself, because Lawsonia is a little bit different from Salmonella. If you normally in pigs, if you have a problem with Salmonella, you have a problem concerning food safety, but not with clinical disease in pigs, and therefore the effects on digestibility, on clinical signs of the pig, and also on the gut itself are quite very small, and therefore I think you will have an effect, but I think if you, for example, compare Lawsonia with Salmonella, you will have a more pronounced effect if you deal with Lawsonia.
I see. Why is it good for us to know that this vaccination can alter the microbiome in this sense?
I think it's one step to know more about the microbiome. It is one step to deal with this pathogen, and I think it's very important to have a good gut health. And if you, for example, I'm a nutritionist, if you would like to have a concept, a dietetic concept to deal with Lawsonia to reduce the pathogen load, it will be very hard. There are, I think 20 years ago, there were the first results from studies who said that mesh diets could be a little bit better, or you could have a little bit lower problems with Lawsonia, but there are no real good concepts from the nutritional point of view to deal with this pathogen, and this is quite a problem, I think, and therefore vaccination could be a good tool.
Yeah, we get to know more and more and more about what is happening on a microbiological level, and these kinds of things support that you can see actually what's happening there.
Yeah, I think nutrition could be a good supporting tool to have a more resilience in the microbiota, and therefore also vaccines will work better, especially those ones who are working in the gut. I think this makes sense, because you need a good core microbiome to have all these possibilities to deal with struggles in the gut.
I see. So is there any future research planned in regard to Lawsonia vaccination at your group at all?
There's a good opportunity to work on this pathogen in the future. A little bit the problem is that it's a hard work to find the right pigs.
Yeah.
And I think the natural infection is quite a good model to deal with this pathogen.
I see. And and for the microbiome research, where do you think that will go in the near future?
I think it mainly depends on the possibilities to get an a good interpretation of the data.
Mm-hmm.
If one knows what are the clinical signs and another person has to organize the data, and then these persons have to deal with each other, this is one point. But the main topic would be the costs, and I think they will decrease hard, and therefore this could be in the future no problem, I think. Sampling and storage until analysis needs to be straightforward and robust. Analysis must become cheaper, and interpretation of the data is the most biggest problem, I think. There are different ways to interpreting the data. So far, you can look on the bacteria. We are looking on the bacteria. Are they normal? Are they normally distributed in terms of abundance? Are different samples similar? And you have then calibrate these parameters by age, by direction of use with animal health and feeding and so on. I think this is quite highly complex, and notating the data is the core problem, I think.
And that will only increase in the future, I suppose. I mean, all these data, they will exponentially grow the amount of data that will be.
Yeah, I think you are right, and you have to think also about viruses in the gut and these effects, because we are now only talking about bacteria and the interaction between bacteria, viruses, parasites in the gut and so on. So
there is a lot more to discuss. Yeah. Before I close off, because I think we've kind of nicely covered it all, is there anything that you wish to address that we haven't talked about before, or do you feel like, okay, no, we've kind of touched on all the subjects that we wanted to talk about?
I think in general we have touched all the topics. I think there are really, you can talk about the indirect effects if you would like to think about suckling piglets and how to prime the microbiota from the first day of life, and to see if there are interactions for the further life if you have a challenge with Lawsonia and so on. And we talked about why becomes one animal diarrhea and the other not, and therefore you have to think to the early development of the microbiota, I think. And you can talk for sure you can talk about boar taint and something like this. Is also an interesting point, or the interaction between Salmonella and Lawsonia, and does it make sense if you have a problem with subclinical Salmonella infections in your farm concerning food safety to, for example, to use the vaccines for Lawsonia, for example. This could be interesting. So there's a lot to do on this topic.
Sounds like we'll come back to you later for our next episode of the Meet the Expert podcast series.
Yeah, could be. In Germany, we have to work up to the 70 years. So I have already 26.
Vielen Dank dafür. Thank you very much, Professor Fischer, for being with us. And I'll draw it to an end because we try to keep it within half an hour, and I see we've already exceeded that a little bit. I trust that our listeners are now completely up to date with where we are with the Lawsonia research, at least at your faculty. I'd like to thank you for being with us very much on this Meet the Expert podcast series. And as a last reminder to our audience, you'll be able to find this episode as well as previous episodes both at the regular podcast channels as well as at the Pig Progress website, and search for the Meet the Expert by Pig Progress and Boehringer Ingelheim Animal Health. For now, I thank everybody for listening. I thank Professor Fischer for being with us. I hope that you'll be with us at the next podcast episode. Thank you very much. Goodbye.